We've been talking about artificial systems to clear waters for a while. However, something very, very similar and similarly actively happens in the coastal zones. Professor DanielConley of Lund University, you are one of the leaders of the COCOA project. Could you tell us shortly why the coastal zones are so important for the Baltic Sea?
Good afternoon, everybody. So the majority of the 85 million people live within 50 kilometers of the coastal zone of the Baltic Sea. And your viewpoint can be from this one, where there's where there's industries. It could be from a port, it could be from a harbor, it could be from an urban area and or a natural area. We use the coastal zone tremendously for our recreation, for both boating and fishing and swimming. And it's where people see the Baltic Sea mostly is at the coastal zone. What we're really interested in, COCO, is trying to figure out what function the coastal zone plays in terms of nutrient retention. Most of the models suggest are using the simple fact that nutrients are exported from the rivers and from the land and go out into the open waters of the Baltic Sea. But we know that the coastal zone acts as a filter. The nutrients come in, nitrogen, phosphorus, silica, and carbon, and they're used by microbes and algae that grow in the water column and in the sediments. Phosphorus can precipitate in the sediments, and nitrogen can be denitrified. And it plays an important role in terms of holding nutrients back before they're exported out to the open system. But we really don't know how big this nutrient retention is. It's interesting, if we start to look around the coastal zone of the Baltic Sea, though, we have very different biotypes. On the left-hand side, we have an example of an archipelago, which is the Stockholm archipelago. We also have the Finnish archipelago. And within those areas, there's very diffuse inputs of nutrients. There's also lots of biological production and very long residence times. So we expect that the nutrient retention within the archipelago areas, for example, would be much longer than in another kind of ecosystem that we see along the Baltic, and that's large rivers coming in and feeding directly into the coastal zone. But it also depends upon the plants that are there, the animals, the algae, and so the ecosystem type that's there. And there's also been large-scale changes through time as we built harbors and removed wetlands. And all of these things have influences on the nutrient retention in the coastal zone. So we're using measurements and models to try and estimate how much nutrients are retained across the entire Baltic Sea coastal zone. This is some preliminary work that we have from the Stockholm archipelago. And in this enclosed area, you can see that 90% of the nitrogen is retained and 80% of the phosphorus, suggesting at least the archipelagos are very important hotspots for the utilization of nutrients and burial of nutrients before they're sent out to the Baltic Sea. But the challenge that we're facing in COCOA is to upscale this to the entire Baltic Sea, to try and figure out the ecological functioning of the coastal zone, and also to learn more about the ecosystem services that it provides. Thank you.